Great. Well, thank you so much for having me. Really excited to be here. Even if it's not in person, I'm glad that we're able to get together remotely. And I would say that during the presentation, if you have questions, feel free to chime in with them. You can just unmute yourself and interrupt me, or if you want to use the chat feature of Zoom, you can do that, and then Drew or Judy will jump in and interrupt me as well. I think that'll make for a better conversation if you have questions that you can bring up at the time. As much as I like hearing myself talk, doing that for just 40 minutes straight isn't good for anybody's mental health. So if you have questions, please interrupt me. And so today I wanted to talk a little bit in depth, actually, about how we at GitLab see the CI/CD portion of the DevOps lifecycle. And for those who may not know, GitLab's a complete DevOps platform, which we deliver as a single application. But before we get to all that, I want to share a little bit of story about how I came to GitLab as a user long before I came to GitLab as a product. So many years ago, I would say the year if I remembered it, but I don't remember off the top of my head, I started working at a government contractor, as many of us in the Maryland, DC, Virginia area have done. And I was there, it was a smaller group, and they'd kind of never had someone look at like DevOps as a whole across the organizations. They would have, different project teams spin up and spin down and bring their own tooling or kind of figure it out as they went along, right? They might do like an R&D project that's only lasts a year, or they might have some longer running project. And so I was brought in to kind of say, how can we kind of leverage that across the organization instead of making it up as we go every time there's a new project? And so I was director of DevOps, I think was the title. And the first day I came in, they handed me an 11-page Word document that was how we deployed the main system that we were deploying to US SOCOM. So not an insignificant customer. And the 11-page document had like, this is the order in which you have to copy the jar files to specific areas, because somehow the order of copying jar files mattered, and all this other crazy things that you had to do in order to deploy the system, which was obviously a pretty critical system for the customer. And so that kind of is what led me to say there has to be a better way, and led me to fall in love with GitLab CI/CD. And hopefully we can, after this presentation, give you a little taste of what I saw and fell in love with then. And fell in love with it so much that now I work for GitLab. And yeah, so if I haven't met you all before, my name's Brendan O'Leary. I'm assuming many people have heard of GitLab and know what it is, but if not, again, we're going to go pretty in depth into GitLab, the software. I'm also going to talk about the company a little bit. I think it's relevant, especially in our current time. And we'll just kind of go through that. If you have questions after today, you can find me on the Twitter at O'Leary Crew, or the Twitters, depending on how you pronounce it. And I'm happy to take your questions there as well, if you think of things after today. So again, today, I want to kind of talk about a few different things. First, what is GitLab? Then why is GitLab? And then GitLab CI/CD, how do? So we're going to talk at it's going to kind of be a little bit of cognitive dissonance for all of y'all, because we're going to go at a really high level, 30,000 feet, why does GitLab exist? And then we're going to dive a mile deep into exactly how GitLab CI/CD works. And I think that's probably over my allocation for analogies already in the talk, but that's okay. So first, what is GitLab? So GitLab's been around as an open source project for a while, almost 10 years actually now, I realized, 2011. But the company itself was founded in 2014 and went to Y Combinator, graduated from Y Combinator, the Silicon Valley incubator, and have been seeing really huge growth ever since then, both from our kind of open source roots, but then also like the open core offering that we've landed on for monetizing the software to large enterprises. Another key focus for us, besides the business that's been growing well, is our values. For one, we've been all remote since kind of the start of the company. Many of us, or many of my friends have been all remote since the start of this pandemic, right? When we all kind of had to shift to remote quickly. And I could do an entire talk on remote. In fact, I did one yesterday morning. But it's a key for us to focus on how these values that we use, they spell out credit, collaboration, results, efficiency, diversity, which is actually now diversity, inclusion, and belonging, iteration, and transparency. And I always say that at GitLab, we talk about these values and our values more than I ever have done in any role in any company ever. And it's a very interesting thing. Like you can read some of the details here. You can actually read 100% of the details because our company handbook is public and actually Creative Commons licensed. You could fork the actual company if you wanted to. The number one thing I think is we talk about how to communicate almost as much as we actually communicate, which is really essential when you're remote. Especially because we're so remote now in our growth that we have over 1,200 folks in 65 different countries, which was, I think, on a previous slide, but worth re-emphasizing. And so there is no, time that works for everyone for a meeting. Because I think we cover, I did the math once, it's almost every time zone as well. There's a lot of time zones, as you know, as developers. But yeah, so this it makes it really critical about, talking about how we communicate. And again, it's a whole presentation that could be on this. And I encourage you to, like, if you Google GitLab all remote, you'll find an ebook we put together at the beginning of the pandemic with like kind of a summary of all of our learnings. You'll find lots and lots of writing in our handbook about exactly how we do it. But today I kind of want to talk more about like, why is GitLab? What has caused this growth? Why has it been as successful as it has been? And I think, the real key is that software has eaten the world. So it's been also over a decade since Mark Andreessen, the famous venture capitalist, said software is eating the world. And I would say it's definitely a past tense sentence if you were to say today, software has eaten the world. And more recently, Mark Andreessen mentioned that cycle time compression is probably the most underestimated force in determining who is going to be a winner and a loser in tech. And winners and losers in tech more and more often become winners and losers in their own industry, regardless of what industry it is. And so the ability to compress the cycle time so that you can kind of skate to where the puck is going to be, this is even a diagram of that fantastic analogy, is really critical for any enterprise, regardless of the industry they're in. It's critical for governments. It's critical for transportation and retail and all these industries that have been disrupted by technology and what it's done for speeding up delivery. But as that kind of happened, we also saw this huge explosion of tools, right? And all of these tools don't really optimize for that cycle time compression, right? They optimize for some part of that cycle, right? They optimize for doing the best job at that part of the cycle. And cycle time actually gets destroyed because you spend all this time integrating these tools together, opening tickets, looking in 10 different systems. The story I always tell here is that before that government contractor, I worked in medical software for a long time. And I was walking from the CEO's office back to my office. I ran engineering at that, as a small company I ran engineering at. And as I'm walking, the server room's on my way back, and the server room doors propped open, which is, of course, never a great sign. And I look to my left where the door is, and there is like my most senior technical developer, software developer, engineer, and he has a server on his lap with a screwdriver in it. And that server was the Redmine server. It had a drive go bad. And he didn't know what to do next because Redmine was down. So he was in with a screwdriver in the server. And that was kind of an aha moment early in my career, where I realized, we're paying this person to add value to our customers. And our customers are important. Like, we were in medical software focused in radiology and breast cancer imaging and detection. And so it's like a really critical thing to add value for our customers. And I've got him in the server room with a server on his lap. And that's kind of when I realized how important it was to, not be spending all this time with tools, and instead, focus on the things that matter. But all this kind of focus on tools, like in large organizations, especially, like, causes a lot of friction, right? Like, there's not this, we have this term of DevOps, but we don't actually like implement it, right? We have developer tools and operations tools, and maybe we try to kind of duct tape them together, which is kind of against the whole point of the term DevOps. Like, we didn't call it developer operations. We called it DevOps for a reason, because it was supposed to be this kind of, coming together of the two disciplines to understand how we can make things flow better, not just, duct tape together our tools. So that kind of is where GitLab, has evolved in, being this kind of single application for the entire DevOps lifecycle. So we have we have a single application that has everything from idea to production, the ability to manage your team, and the issues that need to be completed, and plan out all of the things that are going to be on the roadmap, to, of course, the Git part of GitLab, which is collaborating on source code together, creating merge requests. Sidebar there, we call it a merge request, not a pull request, because you're requesting the server run the command git merge, but that's an argument for a different day. And from merging the code together, to building and deploying the code, CI/CD, that we're going to focus on next, to making sure the code's secure and running security tests and scans against the code, static code analysis, dynamic code analysis, and then also monitoring the code once it's in production. So being able to unite that, and the more that you can bring that into a single platform, the closer to the kind of ideal of DevOps you're going to be able to get. And we see that platform as a single application. There's others that don't see it that way, but still, we've seen this huge consolidation in DevOps tools in the past 5 years, where, there are a lot of consolidation, and everyone's focused on this kind of, how can we have a single DevOps platform? So I think we've definitely seen that proved out. We just are of the opinion that it should be a single application as well. And speaking of our opinion, let's talk a little bit more about our opinionated view of what CI/CD is. So, we kind of talk about, we've talked a lot about, hey, it should be better, it should be faster, but what does that mean? Like, what does good really look like? Well, this is kind of like the GitLab flow we talk about. I've got another diagram of it next, I think, too, that we kind of see as the ideal state, right? You want to be able to say that a developer can, create a merge request on their branch, commit the changes that they're making, and every time they commit, there's going to be a CI pipeline that runs. There's going to be a review application spun up of an actual, running application, so that we can review the change to the application as stakeholders just as easily as, the engineering manager can review the change to the code. Allow for discussion on that, allow for approvals that are required, and then once it's merged in, deploy that into production and monitor into production. So like a step down the flow there would be, of course, in Git, you've got this concept of the working copy to the index to the local repo to the remote repo. And then GitHub flow kind of has this, multiple types of branches that come in. Whereas like the GitLab flow is just kind of, there's one main trunk that's deploying to production all the time. And there's lots of different kinds of Git flows. Again, it's an opinionated view of the world. But we try to solve this challenge of like integrating the Git workflow directly into how you're doing the rest of your DevOps workflow. And, again, the reason for that is we want to, make the tools team not gatekeepers, but people that are enabling developers to like self-serve and get the resources they need so that they can move things to production safely and quickly. And we want to really focus on that because that's a huge push, again, in every industry to be able to deliver better products faster. And we want to be able to, let you do that and still meet the compliance goals of the organization, still meet the security goals that we're all concerned about. And we've been pretty successful with that. Like, if we're going to ask ourselves the question, isn't any good? I mean, again, I like it a lot. I've liked it for a long time. But we've also had huge positive feedback from industry. It's a Forrester Wave report that put us in the top right corner with the highest possible score for strategy and the highest score for our current offering. So we've been really focused on, continuing to evolve the system. We release GitLab every month on the 22nd. We just released 2 days ago. And we're constantly kind of pushing to make sure that we have the best tools available. Another unfair advantage here, of course, is our open core model. So we get hundreds of contributions from the community, either from open source users or even from our enterprise customers every month, literally hundreds that get merged into the code base as well. And that's kind of an unfair advantage. Like, we're not limited by how much money we're willing to invest in R&D. We have this huge, vibrant community of over 3,000 code contributors that are helping us build, like, what is the best DevOps software look like? Okay, so that's enough spiel about why is GitLab. Let's this is the cognitive switch. So everyone's going to switch their brain right now. This is where we're going to have lots of questions because I'm going to switch into like, what is GitLab CI? Like, you've talked about it, Brendan. I'm sold. It's amazing. Now, how do I actually go do it? So first, let's talk a little bit about the anatomy of a pipeline. So we call these kind of, at the highest level, we call it a pipeline. A CI/CD pipeline is a set of one or more jobs that you can run. You can organize that into stages, which are then collections of jobs that run in parallel. So stages run sequentially, and then the jobs within those stages run in parallel. And jobs are the actual thing that's going to go and perform the task, right? So this is where you're running your Maven install or whatever your tasks are for your build. And then we also have this concept of environments, which is, hey, where are we going to then deploy this to? Are we doing a review app? Are we pushing it to a canary build? Are we pushing it to prod? And that all is contained, as code in the GitLab CI YAML file.
Hey,
and that's what we're going to. Yep.
I really hate to be the one to interrupt. I just want to, I think I've already learned something. So if I declare my stages in my pipeline, all the jobs that are inside that stage happen in parallel for free? Like, I don't have to do work to make that happen in parallel?
Correct. Yes. Yes.
Huh. Man, I've been doing some of my pipelines all wrong.
Yeah, so they should. Yes, but there are some conditions that might make them not happen in parallel. For one, you can actually run them out of sequence through the ability to have different dependencies. So I actually could say this thing 3 stages down only depends on one job 3 stages before, and it'll start running actually as soon as this is done.
Okay.
The other thing is what runner capacity is available to me. So we're going to talk about the GitLab Runner. And you set up runners. Like, if you're running on GitLab.com and you just start a pipeline today, yes, it's going to run that all concurrently because we have our own compute that we're just kind of giving you. But if you have your own GitLab runners inside your organization, you may run into a situation where a specific runner that's needed is at its maximum number of concurrent jobs, and then you would end up in sequence, right? Does that make sense?
Yeah, totally.
But there's ways to fix that too. If the runner has more capacity, you can up the concurrency. You could add another runner. There's lots of different ways to fix that as well.
Sure.
You could add auto-scaling runners, right, to automatically scale if you're in a cloud provider of any kind, or VMware or anything. You could, automatically scale up and down how many runners are available based on demand, a number of other things. We actually don't talk about auto-scaling in this presentation, but we can at the end if you want.
Okay. Thanks.
Yeah. So when you're writing the CI/CD pipeline, like I said, it's all kind of as code. And the idea is like, if you can write a bash script to do your build, you can write a CI/CD pipeline for GitLab just as easily. So you kind of take the, like, what are the steps that I'm going to do? Like if I was building on my laptop and deploying it, how would I do that? Like, let's codify that into the repository so it's going to happen the same way every time, independent of me having to remember the right order to place jar files, right, for instance. And then again, what that defines is the ability to build, right? We want to run all of our integration tests, make sure everything is valid. Again, we want to maybe spin up a live preview of our application with a review app. That's something that's easily automatable if you hook GitLab up to Kubernetes. And even if you're not hooked up to Kubernetes, you could manually kind of say, hey, this is how you stand up a review app, so go do it. And then deploy it to your multiple environments. So that could be right into production. That could be, we have a staging environment first. It could be we want to do it into Canary at first and only see it in X percentage of cases and then slowly roll it out. We won't go deep into that, how you do all those different things today, but they're all available. And so an example of like a very simple pipeline as the whole file here might be this, where we're doing some install, we're running some tests, then we deploy to a staging environment, and then we deploy to a production environment. And there's a lot of detail in here, and what we're gonna do is we're gonna take this and we're gonna break it down kind of step by step. But what that example creates is this pipeline. So again, this is kind of an easier way to visualize it. This is how you visualize it in the GitLab interface. And again, those jobs can run independently, maybe on a different runner. Typically, all the jobs in the stage must complete successfully before proceeding to the next stage, with an asterisk, because there's lots of different ways you can do different things. And again, those stages then are in sequence. But let's break down that GitLab CI YAML. So by default, like GitLab's kind of built, one of the huge advantages GitLab CI has over maybe a more legacy product is really just the time when it was built. It was built in a time when Docker had kind of won the day. And so it's very kind of Docker native. It kind of by default expects it's going to be running the build inside of a Docker container. Now, again, there's lots of other ways you can have the runner run. You can have it run, as just a kind of a agent on the machine where it just runs a script against the machine. But if you have Docker or Kubernetes or something like that, you can really easily give the developer the power to say, what should my environment look like for my build? And this is hugely beneficial. At that government contractor I was talking about, I inherited a Jenkins instance. And for those of you that know Jenkins, or at least back when Jenkins was like that, you have to add the tool, like a tool being like Java, SDK or something. And it's actually a free text field for the name. And someone had installed the JRE binary and named it JDK, right? And like, for those of you that have done Java, you know that like very often that's a big problem. And that took forever to diagnose because I just inherited this thing. And like, I literally ended up like shawing the like binary. And then I went, wait, I don't think that you are what you say you are. And again, then I would have developers of different projects that needed different versions of Java, and I'd have to spin up another Jenkins box for this project because it was a very specific thing that this government customer needed. And so the idea of like a build image and, hey, like this is the build image to start from, really frees up a lot of that, right? It's not like open a ticket for the DevOps team to add node 12 to the Jenkins server. It's just call the node 12 image. Or if I need something more specific, I can get really meta. I wrote a blog called Getting Meta with GitLab Build Images. I can, as part of my first step of my build process, if it's changed, build a Docker image that I then do my build inside of. right? So I can really control my build environment and say, like, this is what I want my build environment to look like. And that can be really, really beneficial.
Hey, Brendan.
Yep.
Seeing something in the chat. First, I just want to show, like, we had to have had a collective chuckle on the JDK versus JRE thing. That sounds like, I remember there was a blog post talking about, like, how a single character that looks like the letter R but isn't actually, like, completely mangling some system. But
yep.
They're in the chat. So we got a question in the chat. Says, can you pull from both a private Docker Hub group and the GitLab container registry?
Yeah, so the answer is yes. On the slide, we're seeing like it's pulling from public Docker Hub Ruby 2.3, and then it's pulling from the private GitLab container registry, this other image. But you can actually pull from any container registry. The key is just the runner has to be authenticated to it, right? You're not going to have the authentication in this YAML. But if the runner is authenticated to the Docker registry, GitLab's just doing a Docker pull, right? It's like super vanilla, boring solution. We saw that in the values page. So if you had an AWS container, I can't remember what the container service is called, or a GCP container service, or a private Docker Hub group, or any other container service, as long as the runner has access to that, you'll be able to pull without a problem. And so, like, again, in the AWS world, you could just do IAM, the IAM for that runner could have the right permissions to get to the registry, and then it'll just work, right? And there's a couple different ways that you can do Docker authentication. There's like a JSON file, and there's IAM if you're in a cloud. There's a couple of other, I don't know all of them off the top of my head, but as long as the runner the user that the runner job is running as can access the Docker registry, you're good.
So it's just a matter of configuring the runner with the right credentials.
Exactly.
Okay,
exactly.
Cool. Thanks.
Yep. And okay, so then another part is you might need additional, thank you for the name, John, Amazon Elastic Container Service or Elastic Container Registry. I knew I should have put the word elastic in there. It would have been fine. I'll get 90% of the AWS services with that. So speaking of services, you can also pull additional images to run alongside your image, right? So like if you need Postgres to run some sort of integration tests, you can just say service Postgres, and now that will attach as a Docker service sidecar. I don't know if that's the right term, but sidecar to your image during your build. There's also a super powerful concept of variables that, again, I could probably spend 30 minutes on in and of itself. You get a lot of variables built in about, what is this running from? What repo is it? What's the build? A lot of kind of built-in variables, and then you can also specify your own variables in a lot of different ways. And one way is inline in the GitLab CI YAML, but we'll get to some more details on that in a minute. Then there's also a concept of before and after scripts. So we have the script that the jobs are going to run, but we might want to run something before every one of those, right? And not have to just repeat ourselves in every job. And so this might be like, let's say we just need like one dependency and we don't want to build a whole new Docker image with that dependency. We might just put it in a before script, and then that dependency is there for every job from then on if we need it. Or there might be something we want to remove if we have a specific runner where we're making some temporary files and we want to take it out. Maybe we do that in an after script. And then there's also a concept of caching. So caching is typically things that need to survive for the life of that pipeline. So that you can think of this as things like, I'm kind of a JavaScript developer, so I would think of it as like my node modules, right? I might install my node modules once in the beginning and then cache those, so I'm not doing an npm install every time throughout to do all the different tests and things I want to do. And so cache, and then I only want that to survive for the life of the pipeline because, of course, we could change the module could update tomorrow. And so it'll just cache it, and it'll load that cache before every job and update it if the cache changes at the end of the job. And then again, stages and jobs are of course defined there. So by default, you can just kind of specify on a job, build, test, or deploy, but you can also specify your own stages to be named whatever you want. You can even have emojis in the name for fun and giggles if you want. You can also define like a global image and then define the image in each job. So we didn't talk about that, but that's something you can do. And then, the stages just kind of help you separate the jobs into separate sections. We've kind of been through that. And then the job definition can be like a single line command just with script, or it can be multi-line with a dash for the each line in the script. And then another pattern that some folks like is you can have build scripts that are full bash or command or PowerShell scripts that just run. And then that script is really where the meat of the job runs, kind of like a make script, right? Like you could just run make, or you could have a shell script there. And then again, an optional part of the job is like the environment. If it's going to be creating an environment, you can say, like put the URL for that environment and name the environment there. And then this also introduced this concept of manual triggers. So you can also have some jobs that only trigger when there's actually manual intervention. There'll be a little play button on the job in the pipeline. So like if we only want to deploy to production when someone says, yes, do it with a play button in GitLab, we can do that. And I can, that's another option. And so that's kind of jobs and stages, and it's pretty high level. Again, I don't think it's too complex, but I want to get really a lot deeper next. So does anybody have any more questions before I kind of go into this advanced parts of jobs that we can make really complex pipelines with? Great. Okay. So first, we'll talk about rules. So again, before when we were looking at all those things, we were assuming those jobs were all going to run every time, right? We're going to run the same pipeline every time there's a commit or a change or a merge request or a tag on the repository. But oftentimes, we really want specific jobs to only run given specific definitions. So there's this concept of a rules block that kind of says, gives us a lot of flexibility around when those jobs are going to run. And for those that may not be familiar with GitLab CI, the slide may be confusing because it says new rules block and it has this only and except with a slash through it. Well, there was a concept of only and except, which is similar. It says only run this job if this condition is true, or run this job all the time except if this condition is true. But that was kind of like that is technically deprecated now. It still exists, it still works, but it didn't give you all of the really rich kind of control over exactly when things are going to run that we'll see from this system. And so the reason the slide looks like this is for folks that are familiar and you've done only and except before, highly encourage you to check out rules. And the reason for that, again, is that it gives you this a lot like finer grain control over when jobs run. So I can say if a condition exists, I can say changes, which is then like a regex matching only run if these kinds of files or these files in this folder are changed, or exist, like do these files exist or not. It gives me all the operators that I want, would expect to be able to really be very specific in the logic rather than just only and except like true or false. And then again, gives us the ability to, based on the results, do a lot more. Like, do we allow this job to fail? Do we only run this job when it was manually triggered? Do we only run this job when failure happens, right? So we may have some report that goes out if there was a pipeline failure, and so we only run this job when it's failed. And there's actually a lot, this is the quick reference because there's a lot more detail that you can find if you just Google GitLab CI YAML. So if nothing's defined, right, we assume that like it runs when the previous jobs are successful, or stages are successful, and we don't allow it to fail. But we can then say the job is added based on, again, the when clause. And if no rules match, I don't actually understand. Yeah. So if no rules match, the last clause is assuming that it's only running on success. So again, this gives you a lot of flexibility. And you can also define a global rule for the whole pipeline to say, okay, this is when a job should typically run, and then only define specific rules on your jobs. And so that allows you to do a lot of things. The examples, I think, make it clearer, though. So let's go into the examples next. So for instance, this only is going to run this job if the pipeline came from a merge request event or a scheduled pipeline. So we haven't talked about it, but you can schedule pipelines kind of like a cron. And then again, a pipeline trigger event would happen when you make any commit to the repository and when you make a merge request. So some jobs we might want to run on every commit, right? We might want to just do quick unit tests on every commit. Other jobs that are more complex or include a lot more security rules, we might only want to do when there's a merge request, right? So let developers go change code all they want and they're getting their unit tests. Then when they make the merge request to actually merge it back into the main branch, that's when we run, this more complex set of tests. That's one use case. It's very easily enabled through rules. Or we might want the inverse of that, right? We might want to not run it a certain job on a merge request, right? And so this when never allows us to invert those rules really easily. Or I might want to set some custom variable to a custom string or value, right? And use that to say, if I set this variable when I start the run of the job, don't run it, but otherwise always run it. I may want, to be specific to multiple things, like if there's a variable set and the changes were to the Docker file. So the changes to the Docker file are helpful for that example I was talking about earlier. Maybe and part of my pipeline is I'm building a Docker image to build inside of my pipeline. Well, I only want to do that when I change the Docker file. And so I don't have to do that every time based on changes here. And finally, maybe I want to delay a job, right? I want to run some job some amount of time after the whole rest of the pipeline finishes. So I can schedule, something to run a few hours later or what have you to run after the pipeline scheduled. And so here we see we're running this job when something's committed to the master branch 3 hours later, and we allow it to fail. So if it fails, it's no big deal. We don't fail the whole pipeline. So that's the advanced kind of rules section, and it leads us into the ability to talk about what the kind of advanced pipeline architectures that are available through that, and a couple other features that we'll look at next. So again, we saw this concept of, so this is a visual for the concept of the allow failure. We can see test B here in the test stage failed, but it's allowed to fail. So instead of a red X and stopping the pipeline from running further, it's just a warning. And then the deploy job here has that when manual, so you can see it has the play button. It's only going to run when a person manually says, go ahead and run. And that's kind of, the typical pipeline, right? Kind of straight left to right. But we also recently introduced the concept of a directed acyclic graph, or DAG, to GitLab pipelines. And so this is to say that we can be more specific than stage and job as to what jobs depend on what other jobs. So here we can see there's a build for Android and a build for iOS. Obviously, we could wait for both builds to finish and then run all the tests, but we also could have the Android test run as soon as the Android build is done, and the iOS test run as soon as the iOS test is done. And so that old pipeline graph that we saw doesn't make a whole lot of sense in this case. So there's actually also a new feature that shows you kind of the visualization of what the DAG looks like. And so here we can see a slightly more complex pipeline, but one that shows you exactly, what are the build steps that are happening, and what are the different branches that the pipeline can take, and where are they going to go before we deploy. And so that's kind of one pipeline. But then we could get even more complex than that and say, okay, we want to have what we call parent-child pipelines, right? So a pipeline exists on a repository, but we may build one repository and then need to trigger other repositories to build after that, right? Like this is a dependency for another repository. We might want to run their pipeline and build once we've updated this. So that's where the concept of parent and child pipelines come in. And so here we can see, the parent pipeline running that we saw before, and then all of the downstream pipelines that are run based off that pipeline completing. And that can be either in separate repositories, as I just mentioned, or it could also be, in a single repository if you had kind of a monorepo style repository. So in this case, you can use this depend strategy to make it really clear that there's actually different pipelines for this repository and which depend on which. And then that would make that kind of, sorry, going a little too fast. That would make that parent-child pipeline relationship exist in the single repository, but it can also exist in multiple projects by saying, when this is done, trigger a new project's pipeline. So that's kind of the two ways that pipelines can kind of cascade between projects, either in a monorepo or in separate repos. And then one other thing I want to touch on is the ability to include and reuse code. And this will be the last section, I think, on kind of how the CI YAML works, and then we'll talk about artifacts, and we'll go from there. So here we might say we want to include a local file that's in the repository so that we can kind of organize our build into multiple files, and it brings those YAML files together into one when it goes to run the pipeline, but we can separately manage those and changes to those. We can also, if my clicker will work, hello. We can also do that from other projects or from some remote file, right? So we can include CI configuration from another project. So that might be like, let's say we had a DevOps team that had, this is how we run our Selenium tests. We could just include those in the other pipelines, and we wouldn't have to, rewrite that every time. And then there's also templates that are built into GitLab that you can include. So again, GitLab has the ability to run security tests and those kinds of things. You can just bring those into your pipeline by including local templates from GitLab itself. And then the last way that you can reuse code is kind of it's a YAML spec where you can extend a different part of a job that gets hidden. So here we can see the RSpec tests extends this test section of code. So this is like a kind of advanced YAML usage, but again, lets a lot of code reuse happen.
Hey, Brendan.
Yep.
Is this akin to like using YAML anchors to try to get like, okay, this looks like a more human-friendly version.
Yeah, this is our version of a YAML anchor.
Okay.
Yep.
Nice.
All right, and then the last thing we'll touch on, because I know we're hitting up against that magical 45-minute mark, is artifacts, packages, and pages. So these are just some other features that go a little bit beyond CI/CD. Technically, we put it in CI/CD, and it's part of the pipeline, so I think it's worth talking about. And my clicker is not working at all. It's like everything Bluetooth went away. Okay, great. So job artifacts can save, the output of a job, and it's just a generic kind of save the binary out. And this is, we heard about caching earlier. It survives for the life of the pipeline. Artifacts, have a much longer life cycle than that. And here you can see that artifact can be downloaded from the GitLab UI. You can also, if it's like an HTML based artifact, you can view it right in the UI. So if it's like the output of a unit test or something like that, you can just view it right there. And then you can also get at those binary artifacts through a bunch of different ways, through URL or through the API. And then if you're in a self-managed version of GitLab, you can set defaults for expiration time and a bunch of other things that get configured at the instance level. And then our package registries. So we have a number of package registries, including the oldest one is our container registry, right? We talked about that earlier, GitLab having this built-in container registry. But we also have a number of other language-specific package repository or registries that let you, publish private packages to those different kinds of registries. So like an NPM registry or a Maven repository, etc. You can see all of those there. And then we also have the concept of a dependency proxy that lets you set up a local proxy for dependencies that might be from Docker Hub or other packages outside of, like, on the internet. You can proxy those through GitLab. And then, this is just an example of, being able to push to the Docker registry from within GitLab. And then we can see, we can access the container registry, all of the tags and everything from directly within the project. And the nice thing about this is it gets all of the same security settings that the project has. So you can kind of really control, like, who can see these images, just like you control who can see the code and who can see issues, etc. And then lastly, GitLab Pages is like static web page deploy. So there's a special job name called Pages where you can take a public folder that has HTML, JavaScript, CSS, and you can, just static site, and you can publish that out to GitLab Pages. All right. That is kind of the overview of GitLab CI. The stuff I have after this kind of goes deep into the runner and how it works. But I was hoping to maybe stop and take questions. And if people want to see the runner portion, we can talk about that, but we don't have to keep talking. I'm going to stop sharing so we can all see each other.
So while people muster up the courage or type in their messages, I've already learned a lot of different stuff. When did that DAG feature become available? That just kind of slid in and I didn't even notice it.
Yeah, that's a great question. Cicd, I don't know. It was sometime in 12, I believe. Directed. All of our docs have version history on it. Yeah. So it was first introduced in 12.2, but actually the feature flag wasn't removed to 12.10. So I would say it was really generally available in 12.10.
Okay.
So that's 4 or 5 months ago, I guess. GitLab 12.10 was, GitLab 12.10 was in April. So.
That's not too long ago then.
Yeah, that's not too long ago in real time. Yeah.
Fair.
I mean, yeah, in like pandemic time, it feels like forever ago. But real time, it's actually not that long.
Right. Yeah. You see that in the chat, Brendan?
Yeah. So the question is, can you, just for the recording, can you explain cache versus artifact at a pipeline versus job level? Yeah. So that's a great question. So cache is kind of meant to survive for the life of the pipeline. So the cache, unless you explicitly say in a job, don't load the cache here, it's going to, GitLab will automatically, before your job, like refill the folder from cache, and at the end of the job, if it's changed, zip it up and send it to the next one. So again, cache is kind of, but it's not, cache doesn't survive after the pipeline. So it's really for things that need to travel through the lifecycle of the pipeline. Like I said, like your M2 repository for Java or your node modules for Node. Those kinds of things make a lot of sense to cache because then you don't have to like recreate them each job, right? You can save yourself a little bit of time. Artifacts. So artifacts have existed for a long time in GitLab, and it's kind of like just any binary data that you want to save after the pipeline, and you want to have it. I mean, you can have it be around forever, or you can say it expires in 30 days or it expires in a day. And so it's something that you want to reference after the pipeline's run. So again, a very common use case for that. And in fact, there's specialized artifact types for things like the output of unit tests, right? If you output junit.xml and say it's a unit test, then GitLab shows you the results of that unit test in the merge request, right? That's an artifact of the job or of the pipeline. And then we also, before we had package registries, we were like, well, if you want a package, you could put it in a binary and call it an artifact, right? You could make it a jar file or whatever and have it there. I mean, now that we have this like first-class support for all those languages you saw in package registries, like that's the way I would say if you're making a Node package or you're making a Conan package or you're making a Maven package, like put that into the registry. And that was the thing I always wanted because, again, I inherited at this contractor like the typical stack, like Jira to GitLab to Jenkins to Nexus and Artifactory. For some reason, no one could ever explain to me why we had both, right? And so the thing I always wanted from GitLab before I worked there was like, if you had a Maven repository, I could get rid of everything else. And so I'm really excited that's there now. But before that existed, we had this concept of artifacts. But artifacts are super useful for like test results, right? And so I didn't go into it, but there's like a number 6 or so specialized artifact types that GitLab then reads into the merge request a lot better. Like I know off the top of my head that JUnit XML is one. You also can just have like metrics, like just a generic like comma separated value, I think, or you can look at it in the documentation, metric to say, is this going up or down? So like you could run a speed test, save it as a metric, and then every merge request, is it going up or down? So those are the kinds of things that artifacts are really useful for today. Hopefully that makes sense. Does cache survive runs between pipeline executions? So cache, yes and no. So cache is defined as like best effort, right? So it can survive a pipeline run, but we would say you can't count on it surviving the pipeline run, if that makes sense. If you have to count on it surviving the pipeline run, save it as an artifact.
If I can give another half question, rolling back to the comment about metrics. So like you can hijack the artifacts keyword to be able to like just track the speed of a given job. Like you can just track over time how quickly a given project will build.
You could.
Yeah. That shows up as an artifact, like viewable in the web UI.
Yes. So let me just show you what I'm Googling because that'll help. Move this over there. So yes. So I'm going to go to this page that I like a lot, and it's very useful once you know GitLab CI, but isn't super useful if you don't. And it's this GitLab YAML reference page. So this is the reference for like everything you can possibly include in the GitLab YAML, which is great when you're Brendan and you've been using GitLab CI for a bajillion years. So if we look at artifacts, there are specific kinds. Is it expose as? Sorry. Well, so expose as is for just a generic file. So you can just say like, if this is text file, like I want you to link it from the MR. But I think there's a concept of like if I do, what is the artifact keyword for? Yes, okay, reports. Sorry. So artifact reports, these are the different reports that can come out of GitLab. And then they come into the merge request. So there's things like code quality, like that's our built-in code quality. and you can do that. Container scanning, right? JUnit, right? We talked about JUnit there. And then metrics is a specific type that collects metrics as artifacts. So you can define just metric name and value. And okay, can you show me an example? Okay, so here you go. Here we can see the output. So here we can see the output of these metrics that were shared. That's based on the open metrics kind of Prometheus metrics format. And then you can, these are all new in this example, but if they were not new, you can see if it's gone up or down over time. So if that makes sense.
That is really cool.
Yeah, thanks. I actually was product manager of our CI product when I added that. I wanted that. So yeah, it's cool.
Nice.
Now for things like browser performance, there's also like browser performance. So if browser performance is a critical thing to you, you can do specific things around browser performance testing, like how fast do pages load and first contentful paint and all that stuff. If load performance is really critical, we use K6, which is like a load tool that puts load against something and gives you like specific metrics out. But metrics is like just what generically do you want to track? And in fact, I think the first use case that GitLab used it for was actually for what you were just saying, Drew, which is like how are we making our pipeline slower or faster for GitLab itself? Like I wonder, well, looking at the GitLab CI YAMLs is complex, but you could probably find a use of artifacts metrics in there. Now I lost my chat too. If there's more,
I'm not seeing any other questions.
Okay.
In the chat.
Cool.
Cool. Yeah, I'll stop now. If you want to go on to moving the runners.
No, yeah. So yeah, I mean, if you all want to stick around, I'm happy to talk about runners. So,
we got a couple affirmatives. We're here.
Okay,
We're
awesome,
in.
Fantastic. I haven't bored you completely yet. So I've just got 10 or 15 slides on runners. All right, so we've talked a lot about how, like, what the jobs are and how great they can be, but they've got to run somewhere, right? Like you've got to have compute to run it. And the way that happens is through an application called the GitLab Runner, which is written in Go. And the beauty of that is it makes it super cross-platformable, right? So you can run it in Linux, on OS X from Apple. You can run it on Windows. You can run a whole bunch of places. In fact, most recently we worked with IBM. It's running on Linux for ZOS on Z machines. Yeah, exactly. Drew just made the face, but yeah, it's awesome. I don't doubt that I will try to get it running on my Commodore 64. Like Googling Commodore 64 Go port is going to be a thing that happens in my life. And then I can expense it, right? Yeah. Okay. Okay. So each runner environment that it runs in can have multiple processes, and you can have an unlimited number of runners, right? Like it's however many you configure. And you can have those for an unlimited number of environments, right? You might have some OS X runners for iOS builds, or Windows for Windows builds, and Linux for other stuff. You can even install the runner on your laptop, right? You can have 0 to N runner servers and runner processes running on each of those. And then each runner has some critical, this is going to go to Drew's first question of the day, some critical properties that help us understand like what jobs are going to run and when on this runner. So runners can be shared or specific, tagged or untagged, and protected or not protected. So let's talk about what that means. So shared runners are ones that are connected to the instance, the GitLab instance at that level. Like your GitLab admin can connect them to the instance, and then can be used by like any project. So it's like a big pool that any project on this GitLab instance can use. And so typically this will be auto-scaled, right? Because you're going to have an unknown amount of load on the instance. Like for GitLab.com, which is just an instance of GitLab that we run. It's actually the same exact code we ship. We have shared compute that is auto-scaled machines. We actually one-to-one job to actual machine on GCP. So for every new job, we create a new machine in GCP, run the job, and destroy it. And so that obviously is like scaling throughout the day. You can just watch people wake up in Europe and then wake up on the East Coast and then wake up on the West Coast, right, throughout our kind of day there. Or you can have a runner be specific, which is then tied to one or more specific projects, right? So then it's only going to pull for those specific projects it's allowed to. So again, you can have the runner attached to multiple projects, or you can attach the runner at the group level. So for instance, if you're a GitLab.com customer, you would have a group, and then you might attach your own runners to that group. And so that's typically for like specialized builds, or if like you're going to have to, you don't want to run, you're the tools team, but you don't want to run and pay for shared compute for everyone. Right? And then a runner can also be tagged or untagged. So I can tag a runner with kind of like the capabilities it has, right? And then that runner is only going to be used to run jobs that have the same tag, right? So I might tag a runner to say this is a Windows machine, or a OS X machine, and then I can tag my jobs that depend on that to run only on those. And then untagged runners are, unsurprisingly, used to run jobs with no tags, right? So here we can see, this example here is Windows, right? Like I'm running like a MS build, and so that's going to need to be on a Windows machine versus I'm just running some Java stuff that can be on any available runner. And then runners can also be protected or not protected. So this is a really useful thing when it comes to like deploying code to production. So protected runners will only run jobs from protected branches or protected tags. So typically this is like key if we say that, well, this runner has permission to do stuff in production that we don't want just anyone to arbitrarily be able to write code against. And so if they can only run jobs from protected branches, then we know that our merge request process that has all of our compliance and security and all that stuff built in happens before any code gets run on this runner, right? Versus a not protected runner, again, can run jobs from any branch or any tag and be used for any build. And there's a few other options too. You can actually say, do I run untagged jobs or not? Like if I'm a tagged runner, you can lock it. There's a number of other things you can do with runners as well. I do have an example project of running lots of things at gitlab.com/allthethings, which is where I haven't fed and watered it very well, but I was trying to make GitLab CI run all the things. And the reason for that is like there's also this concept of platforms and executors, right? So first is the platform. Again, we can run basically anywhere that can run Go code. In fact, I mentioned that we're running on Linux for Z. They're actually working on making Go compiled directly to Z, and then we'll run on Z itself, which would be cool. Again, if I can get Go compiling on the Commodore, it'll be there. And we can also run, there's a Kubernetes runner where you can use, Elastic Compute from Kubernetes to run there. And then there's also the kind of executor, right? So there's a number of different ways we can say that we're going to have this runner execute the jobs inside of it. So the most common, again, it would be Docker, right? Like I'm going to give you a Docker image, you pull that image, and then run my job inside of it, please. But I also could say it's just a shell runner, and I'm just going to directly run commands just like I was, just sitting on the shell and running those commands. There's a concept of Docker machine, which is an older concept for auto-scaling. There's actually new auto-scaling features coming, like you can scale directly in Fargate and a number of other things now. And then again, you can run in Kubernetes on a Kubernetes cluster. And then there's some like lesser used, excuse, these slides are out of order. Like you can run inside of VM on VirtualBox or run in parallels, or SSH into a machine first and then run. Like if you don't want to install the runner on the machine, but you have to SSH into it to do something, you can do that. And then auto scaling. So again, most of our larger installations will involve some sort of auto scaling. You can do that in AWS or your cloud natively. The Docker machine project allowed us to do it across, basically any kind of cloud, public or private. That project's going away, so we're going to be doing our own extensions to do each of the clouds that we'll maintain directly. And then, of course, Kubernetes, which allows you to use the executor as a scaling method there and install it within Kubernetes. So this goes into Docker machine as kind of a way that you can say, hey, give me a new machine, and you can set up a bunch of limits. We won't cover that too deeply. For AWS, you can do a lot of great things. A lot of the same stuff applies to GCP or Azure, but AWS is where we've done a lot of work. But I mean, again, like things like putting distributed cache into S3 works with any S3 compatible object storage. And then for EC2, you can use things like spot instances to make sure that you're running the compute as efficiently as possible. Kubernetes, again, really easy to get elastic compute from, but there are some considerations here. Like, do you need access to the same volume every time? Do you have Helm and Tiller? Is that part of your stack? Because that's really the easiest way to deploy it. Yeah, that's basically the runner overview. All right. So questions about runners, how they work, what you can do with them.
I've got one to start it off.
Sure.
So like we have a Kubernetes runner. You had said that runners have a concurrency property. So like, can I just dial up the concurrency on a single Kubernetes runner? Or would I like, how can I easily just maximize my usage of a K cluster?
Yes, that's a great question. So you should be able to, I'm trying to figure out exactly how right now. I'm going to send you this documentation and we're going to look at it together too. Sorry, too many windows. Okay, great. So yes, there is a concept of concurrency, right? The number of concurrent jobs that the runner can run. That's something that's set through like if you deploy it with Helm, that's set through the values.yaml. If you have an older version of the Kubernetes executor, you might not have deployed it through Helm. So I would say like go through these docs and redeploy the Helm way. Because that lets you say, okay, what's the concurrency for it? Like how many jobs are going to run? And then there's other limits too that I just wanted to find. Well, that's just what is the container going to be? I think that's it. Maybe that is it. Maybe it's just that concurrency.
Yeah, so that makes sense. So that means like, so if the default concurrency is 10, just as an example, that means a single Kubernetes GitLab runner will be able to run up to 10 separate jobs.
Correct.
Okay. And whether that's like one nightmare pipeline with 10 jobs in it or 10 separate pipelines, it doesn't matter.
Exactly. Okay. Yeah. And I mean, you can get to 10 jobs pretty quick. Like,
oh yeah.
If we look at GitLab, building GitLab, which is just basically always running. I think it's something on the order of like 150 jobs for an average pipeline, 137 jobs in this pipeline. So you can get there when you're building something for Rails. You can get there real quick.
Sure.
I'm scared to click this dag. I'm going to do it live. Oh, look at that. Good job, GitLab. I was like, this is definitely going to demo God fail immediately. So yeah.
Yeah, I was overthinking it. That's a lot easier than I thought. Just ask for more.
Yeah, just asking for more should be as easy as it is. But that concurrency is true of every executor type. So like even if I was doing a shell executor, I can run multiple ones concurrency, but of course that, might be bad if, I'm using the same folder, right? Obviously in Kubernetes, I'm spinning up a Docker, a separate pod. It isn't going to be a big deal. And there's a lot of other settings. If we look at, so if you also look at so the GitLab Runner, I didn't go into it in detail, but the configuration for it is controlled for, I guess for Kubernetes is actually in the config map, but for everything else, it's in this config.toml. And there's a lot of things that you can control about the runner itself. Like for Docker, for instance, you can control like the memory it's going to use and all that kind of stuff. And then the global setting of concurrency obviously is going to limit it. So that's another article you might check out because it may be relevant to those folks that want to do some advanced stuff with the runner.
Got it. Thanks.
Mm-hmm. And then that also has auto scaling. Like if you want to auto scale on EC2, it has kind of the details of how to do that. It has how to do it onto AWS Fargate, and a lot of other auto scaling. Just kind of generically, how do you auto scale with Docker Machine? That's all in those docs as well.
Very cool. I'll pause for another couple of seconds if anyone wants to jump in with any questions or comments or even anything in the chat. I think we've definitely pushed up and approached that end of the workday post dinner.
Yep. I would just if I could make one more plug, Drew.
Yeah.
Again, we've written a lot about working remotely and are very opinionated on that. I think I said it earlier, but I would definitely say you should check out, if you Google GitLab All Remote, our All Remote guide. We've written a lot about going remote in an emergency like we all have experienced, and how to lead in those scenarios, how to be an individual contributor and look after your own mental health in those scenarios. So I highly encourage everyone to take a look at that if you haven't.
Yeah, thanks, man. And I've got that link that's going to be part of the send out to the crew.
Awesome.
To this. We did get something in the chat. So, back to concurrency, multiple runners. So on a single host, should you register multiple runners or just raise the concurrency of your existing one?
Yes. Yeah. So registering multiple runners is useful if you want to have different configurations. So maybe I want to have, differently. Maybe I want to allow with tags only one type of this tag job, but 100 of this other job, right? So then I could have two registrations, one with the tag that says concurrent 1 and one with no tag that says 100. So registering different runners should happen when the configuration of the runner is going to be different. Otherwise, I would say most of the time, if you've got the compute for it and the thing's running, just up the concurrency if it's the same configuration.
Yeah,
but be careful, as everyone wants to be careful with your AWS accounts.
Okay, I'll give it another count to 10 for anybody else to chime in or drop something in the chat. I think we are approaching about that hour. So we got the last plug for the y'all remotes. Anything else? Any parting thoughts, Brendan?
No, I think that's
favorite
it.
Places to find you, or?
Yeah, find me on Twitter at O'Leary Crew. I'm on LinkedIn as well. You can email me, boleary@gitlab.com. I check that occasionally. But easiest way to get in touch with me is on Twitter. So happy to follow up with any questions folks have. And thanks so much for having me, Drew.
Yeah, thank you, man. All right, thanks everybody. And everybody take care, stay safe, and we'll be in touch.
Thanks all.
Bye.